Professor Göran Johansson, member of the committee of the Nobel Prize in Physics. What is this year's physics prize about?
So this year's physics prize is about putting quantum mechanics, which we know from the subatomic world of electrons and subatomic particles, onto such a chip, electrical circuit on a chip.
Okay.
So you can study it on the chip. Yeah.
Tell us a little bit more. Why is this important?
So, because you can engineer the circuits on the chip, you have artificial engineerable atoms. So instead of having sort of only the natural atoms, you can explore new parameter regimes. You can increase the coupling between, for example, an atom and a cavity, if you like, because there are lots of theories about this. And then in this kind of systems, you can look at different aspects and check that quantum mechanics works.
And why is this such a breakthrough discovery, would you say?
So there were two breakthrough experiments performed in 1985, demonstrating that you can actually do these artificial atoms on chip. And since then, we had 40 years of development of many groups in the world, an ever-increasing number of groups, exploring quantum physics on chip. And it's also been driven by the quest for realizing a quantum computer. So that's, of course, something that's been driving this effort as well.
But today we don't have the quantum computer yet.
No, there are small quantum computers, both made with this type of technology, but also with other, with this type of technology, but also with other types of technologies. But they are not big enough, and they are not good enough to actually be useful yet.
So what is this technology useful for today? Where can we find it in our everyday lives?
So today you don't find it in your everyday life, but it's really an discovery that opened up our understanding for how that quantum physics can appear also on this scale. I mean, you can actually see there are 9 artificial atoms there. Do you
Yeah, I see it.
Yeah.
You can show it to the camera.
Yeah. So, so that's on that silvery surface there.
And if you should tell us a little bit about the laureates, do you know them?
Yes, I've met them, all 3 of them, and yeah, I work in the same field. John Clark, he was really surprised when Hans Ellegren phoned him. So
you heard the call?
I heard the call, yes. And it was really delightful to hear his surprise, and he was of course also very happy, yes.
And tell us about them.
Well,
Who are they?
I talked to him, and he is a friend of Brian Johansson, as he mentioned. So he really, I mean, this connects to the prize to Brian Johansson in 1973. I think that's, it's really an interesting connection.
And the other 2 laureates? Who are they?
Michel Devoret. So he is a Frenchman. So he got his PhD in Paris. Then he joined Saclay, what we today call CEA Saclay, outside of Paris. And so there, after this 85 breakthrough experiments, he started a group that really made efforts on, he really developed this type of quantum physics in electronic circuits.
And then we have John M. Martinez.
And John Martinez, so he spent time at NIST in Boulder, and then he moved to Santa Barbara. And maybe you heard that he also led a group at Google developing a quantum computer.
But all this happened in the mid-80s.
These breakthrough experiments happened in the 80s.
And
exactly.
Why now? Why the prize now?
I think that now it's clear that this really inspired so much work, and it opened up our horizons so much that it's really for the best of mankind.
And finally, if you would explain this prize in 30 seconds, what would you say?
I would say that this really brings quantum physics from the subatomic world onto this chip. So I think that's it.
Thank you so much for explaining this to us.